Okay, so let's do another example. We've got another line here. We're going to find the equation of that line in slope-intercept form. What two things do I need to find the equation of a line in slope-intercept form? The slope and the y-intercept. See if you can do that on your own. Okay, so somebody tell me the slope of this line. 3 over negative 4? Everyone else agree? I disagree. 3 over positive 4. It's a positive slope, right? As our little man goes left to right, what was his name, Fred? As he goes left to right, is he going uphill or downhill? He's going uphill. Okay, so it's a positive slope. Right? Again, just choose 2 points that you know on that graph. It'll be those 2 points there. And figure out the rise compared to the run. That's a rise of 1, 2, 3 up, and 1, 2, 3, 4 to the right. So 3 over 4 would be the slope. Y-intercept? Negative 1. So the equation therefore is y equals 3 over 4x minus 1. How many got that? Where'd you guys get stuck?
I just got the signs.
Got the signs mixed up? What else? Okay. So just a tiny error. That's good. Alright, so I thought for this next graph, it would be helpful to actually have the line that we're trying to graph. So here is that line. And we're going to try to, well, we've already got an equation. We're going to put that equation into our calculator and see if the graph of that line looks like this graph that we have over here. Alright, so go back to y equals and clear anything that's there. And we found the equation of this line to be y equals 3 over 4x minus 1. So we're going to put that in. 3 over 4, make sure the 3 over 4 is in brackets, and then x. And again, I want to use the subtract 1, right? Not the negative sign this time. I want to use subtract 1. I go up and hit graph. And again, if you do not see that window, just go to zoom and hit option number 6, and that should give you a standard window settings. Okay, so this graph over here kind of looks like this, right? We wanted it to cross at negative 1 for y, and it kind of looks like it does. Again, to make sure, we can press trace, and if it doesn't say this right away, you can just press 0 for x, and if negative 1 pops up for y, then the point 0, negative 1 is on our graph line and is on our picture line, so we suspect at least that these two graphs are the same. To give us further confirmation that they're the same, we can pick some points on this line that we know are there. For instance, this point right here is 4, 2. Okay, we want to make sure that 4, 2 is also on this line. So to do that, we're going to press trace and input the value for x. So we put 4 and then press enter. And if 2 comes up for y, then we know that this point is also on our calculator screen. So it gives us an even deeper confirmation that this is the correct line. So we should get 2 for y. There we go, we do. And we can test, another point? It doesn't look like any of the other points are on here. Okay, so I guess those are the only 2 points. But there are 2 points here that we know are on the calculator screen and in the diagram in your notes, so you can say with a relative degree of confidence that these are exactly the same graph.